Good day, class, and in this video lecture we will be talking about our functional groups. So what are our functional groups? Functional groups are structural features that make it possible to classify compounds into families. A functional group is basically a group of atoms that has a characteristic chemical behavior in every molecule where it occurs. The chemistry of every organic molecule, regardless of size and complexity, is determined by the functional groups it contains. So what gives the reactivity, the chemical capability, and the different properties of our compounds is not with the compound itself, but it is with the functional groups present in that compound. And that is why it is important for our in organic chemistry to study our functional groups. So to start, we have functional groups with carbon-carbon multiple bonds. These are the very basic functional groups, and usually we don't identify them as such in more complex structures. So first, we have our alkanes. These are saturated and only carry single bonds. There are no other bonds present in the structure except single bonds. So for hexane, or let's have ethane. There's no, it only contains a single bond. It is saturated. When we say saturated, it means that each carbon contains the maximum amount of hydrogen, and there are no other substituents, or there are no other presence of double bonds. Alkenes, on the other hand, are unsaturated, in which they contain double bonds, like our propene. So this is our propene. Alkynes are also unsaturated, and they contain triple bonds. So these are your alkynes. Next group is functional groups with a carbon singly bonded to an electronegative atom. So having a carbon singly bonded to an electronegative atom, like our halogens, oxygen, nitrogen, or sulfur. In all cases, the bonds are polar, with the carbon atom bearing a partial positive charge and the electronegative atom bearing a partial negative charge. So take for example, you have C, X, in which X is an electronegative atom. Carbon will carry a positive charge, and electronegative atom will have a partial negative charge. So the first one is our alkyl halide, or our RX. So in the rest of the lecture, we will be referring to R as the extension of the structure, but R always starts with carbon. So in the case of RX, it could be CH3, X, or CH3, CH2, X, etc. We just use R to describe the rest of the structure, and R is always carbon, starts with carbon. So alkyl halides have a carbon attached to a halogen, which is represented by X. So halogens is our chlorine, bromine, iodine, and fluorine. So alkyl halides are usually like this one, like our chloromethane and our dichloromethane. methane. These are simply carbon compounds in which there is a halogen attached to one of the carbons, RX. Next, you have your alcohols. Alcohols have a carbon atom bonded to the oxygen of a hydroxyl group. The hydroxyl group is your OH. So let's have ethanol, CH3, CH2, OH, or to draw it slightly differently, this is your ethanol. The hydroxyl group is attached directly to one of the carbons in the R group. So that is your alcohol. Next, you have your ether. Ethers have at least or have two carbons bonded to the same oxygen. So it needs to have one oxygen in between two carbons. Okay. R apostrophe or R prime, it signifies that it may or may not be the same substituent. Take for example, here you have diethyl ether, CH3, CH2, O, CH2, CH3. So this is your diethyl ether. This is still an ether because you have R, O, R. However, this is also valid as an ether, CH3, CH2, O, CH3. R prime, O. This is still valid. The point is, there should be an oxygen between two carbons. Next, you have your organophosphates. These are similar to your ether, but instead of another R group, you have the phosphate group. So you have R, O, then phosphate. So this is your organophosphate. In the case being in this here, CH3, O, PO, Next, you have your amines. Amines are R and H2. Please take note that it is only connected to carbon. So you might be confused later with our amines and amides. So these have a carbon atom bonded to a nitrogen compound. So in this case, you have your methylamine CH3 NH2. You have your methylamine. Next, you have your thiols. Thiols are similar to or alcohols, but instead of OH, you have your SH added to the carbon atom. So if you have CH3, OH, this is the thiol counterpart. Please take note that this is usually it is required that S is bonded to H. Likewise, that H is bonded to O in alcohols. Next, you have your sulfide. Sulfides are the sulfur equivalent of our ester. Ether. So these have two carbons bonded to the same sulfur. Okay, so the formula is R S R. So the simplest would be CH3 S CH3. Dimethyl sulfide. Also applies to our ether, in which R and the two R's may or may not be the same. So in this one, you have your ethyl sulfide. S R prime. Next, you have your disulfide. Disulfides have carbon atoms bonded to two sulfurs that are joined together. So these are similar to your sulfide, but in this case, you have two sulfur atoms, hence the name disulfide. So this compound is CH3, SSCH3. This is your disulfides. So disulfides are frequently found in your biochemical substances. Next, you have your functional groups with a carbon-oxygen double bond. So these are your carbonyl groups or carbonyl functional groups. Carbonyl is simply C double bond O. You have to remember this since every time you're gonna see C double bond O, it is usually a functional group. So the functional group with a carbon-oxygen double bond are present in the great majority of organic compounds and in practically all biologic molecules. These compounds behave similarly in many respects but differ depending on the identity of the atoms bonded to the carbonyl group. So you will see later that R, C double bond O, is the standard part of our carbonyl group. What differs or what makes it different is the substituent attached to the carbon double bond O, or the carbon with the double bond O. Okay, let's start with our aldehydes. So our aldehydes is our RCHO. Why is it RCHO instead of RCOH? It's because you can confuse it with an alcohol instead. If you put it RCOH, it will look like an alcohol. So instead, the notation is RCHO. So this has at least one hydrogen bond to our carbonyl group. The functional group is terminal in nature, meaning it is found in the ends of compounds. You cannot find it in between or in the middle of the structure because it is needed to have at least one hydrogen bonded to the carbonyl group. So the simplest one is CH3, which is our R, C double bond O, and hydrogen as the final substituent. This is your aldehyde. Next, you have your ketone. Ketones are similar to your aldehydes, but in this case, the functional group is found in the middle of the structure. So I take, for example, we have our acetone R, C double bond O, and finally another R. R, C double bond O, R. This is your ketone. Next, you have your carboxylic acid or RC double bond OH. Carboxylic acids have an OH group bonded to the C double bond O. So in this case, CH3, which is our R, C double bond O, R, C double bond O, and finally you have an OH at the termination of our C double bond O. Okay, you might get confused with carboxylic acids and alcohols. Carboxylic acids is C double bond OH. This is your carboxylic acid, while your alcohol is simply OH. Okay. The key here is the C double bond O. If the OH is bonded to C double bond O, it is a carboxylic acid. If not, it is a basic alcohol. I hope that makes it clear. Next, you have your esters. So esters have an ether-like oxygen bond to our C double bond O. So it behaves like our ether. However, in this case, you need a carbon double bonded O. So R double bond O, carbon double bond O. You need another R. Please take note. You need another I'm so sorry. You need another oxygen first before you have your ester. You have another R group. Okay, so esters are R, C double bond O, O, R. You might get this confused with our ketone. Ketones are this one. What separates them is the presence of an oxygen between them. There is no oxygen here. This makes it makes it a ketone. This is our ester. Okay. Walang O sa ketone. Walang dagdag na O sa ketone. Sa ester, merong O bago mag-C uli. Next, we have our amide. So amides has this amine-like nitrogen bonded to the C double bond O. So in this case, you have ethanamide, CH3, which is R. Then you have your C double bond O. Then you have your NH2. This is your amide. Okay, you might confuse this one with an amine. An amine is simply directly connected with our R group, while for amide, you need to have a C double bond O, which is connecting to your nitrogen. Amine directly to R. Amide, there is a carbonyl group present. Okay, let's summarize our carbonyl constituents. So the simplest is so let's start with our aldehydes. R, CHO, CH3, C double bond O, H. Next, you have your ketone. You have R, C, O, R. R, C double bond O, R. Let's R, R, R prime. Ketone. Let's have our ester. R. Oh no. It's not RCOR. It's yes, it's RCOR. Sorry. Ester is R, C, O, O, R. CH3, which is our R. C double bond O. You need another O. Then you have your R again. This is your ester. R, C, O, O, R. So please don't confuse our ketone with our ester. Next, we have our carboxylic acid. Carboxylic acid is our C, or our R, COOH. R, C double bond O, OH. Next, we have our amide. Amides are RCONH2. R, C double bond O, NH2. So that is all our carbonyl functional groups. Let's have another one to separate carboxylic acids and alcohols, our ether and ester, and our amide and our amine. So let's have carboxylic acid versus alcohol. Carboxylic acid is RCOOH, while alcohol is simply ROH. Let's have R, which is CH3, C double bond O, OH. This is your acetic acid. And let's have alcohol, R, directly OH, and this is your methanol. Okay, so the key characteristic here to see is this one, carbonyl groups. If your oxygen or your hydroxide group is connected to a carbonyl group, it is a carboxylic acid. If it is directly connected with your carbon, no carboxylic group, no carbonyl group, it is an alcohol. Next, we have our ester and our ether. Ester is RCOOR, while ether is ROR. The key here is there is a carboxylic group with our ester. So we have our R, C double bond O, OCH3. Well, for our ether, it is simply R, O, R. So that is your ester and your ether. And finally, we have our amine and amide. Amine is simply RNH2, while amide is RCONH2. Amine is simply, the simplest one is CH3 and H2. Our amide is CH3, carbonyl group, NH2. Okay, so that is the comparison between your amine and our amide. So I hope this clarifies things for you. The lecture is posted in our Moodle, and a handy guide will also be posted. So thank you for listening, and this will be the end of the video lecture. I hope you have a pleasant day ahead. Thank you and goodbye.